So for our topic, we chose cryptography in relation to cryptocurrency and in specific blockchain. So a communal ledger is what holds all transaction data and records. And there are a few key ideas to understanding communal ledgers or blockchain, and these are decentralized databases, transaction records, consensus mechanisms, and immutability and transparency. So a decentralized database is where data is distributed across nodes, which are computers that are participating in the blockchain, and each node maintains a copy of the ledger or a portion of it. And this means that there's no single entity that is in control of the data and they can manipulate it. And also, changes or updates are propagated to all other nodes in the network via consensus mechanisms. Because the data is distributed, it ensures the data is accessible in event of a node failure to all other nodes. In blockchain, a block is a data structure that serves to represent a transaction or transactions between a group. To ensure the integrity of a transaction, details of the transaction are often hashed together, which produces a unique identifier. Each block contains metadata such as a timestamp and amount of the transaction and a previous hash of the transaction that occurred beforehand. It also stores information about participating users, such as their public address, which is just a cryptographic representation of a user's public key. Digital signatures are also stored in the blockchain, and these occur when a user initiates a transaction and they sign that transaction with their private key, thereby creating a digital signature. The blockchain serves as a record keeper and holds all of these transactions. In terms of the consensus mechanisms, we'll talk about proof of work, which is commonly used in blockchain, and it uses a function called SHA-256 for hash generation. And what this does is it generates a hash for a block of transactions, and it can produce a fixed hash value from any amount of data and any data. And this is key for hashing together the metadata and data related to the transaction. And miners can also use proof of work and the function SHA-256 to compute the block header or the previous hash and calculate blocks. Miners who find valid hash values for blocks are rewarded tokens or cryptocurrency for their efforts, which is proof of work. In short, proof of work is a consensus mechanism used by many cryptocurrencies to validate transactions on their blockchain. It relies on hash functions like SHA-256 to generate hashes for blocks, and miners compete to validate these hashes. Proof of work ensures agreement among network participants and helps secure the blockchain against tampering and fraud. The ledger or blockchain is also immutable. This means that once data is recorded to the ledger, it cannot be changed. And to further preserve this immutability, each block has a hash, as we mentioned beforehand, which serves as a unique identifier. And additionally, each block includes the previous block's hash, linking all the blocks together. So each block is cryptographically linked to its predecessor, ensuring integrity and immutability. Also, the ledger is open and publicly accessible to anyone with an internet connection. This ensures participants can independently verify and validate the authenticity of transactions. Moreover, copies of the ledger are in sync on all nodes in the network, and this prohibits tampering as they are all updated in real time, so it ensures everybody is using the same ledger.
To get an idea about all these different terms, we have an example to work through in order to learn how they work. For example, if we have a ledger between people and they want to make a transaction, let's say Alice wants to pay Bob $10 and Bob pays Charlie $20, each one of those lines will need a signature to prove that the person paying acknowledges the payment. Each signature is unique to its transaction, even if it's made by the same person. In order to get this signature, exactly the same way we've learned in class, there's a signature function to generate this signature based on their private key, as well as a function to verify if the signature belongs to the right person. Now, it begs the question, how do you keep people accountable for making these payments on the ledger? This is done by allocating X amount of money to each person, and each person is not allowed to make payments that go beyond this allocated amount. This is not real money, but rather a boundary value to keep everyone accountable. So we can see Alice has $100, Bob has $100, and Charlie has $100. And basically, they cannot make any more payments to this ledger that exceed $100. So one might wonder, where is this ledger? Well, it's somewhere in the public space where people can add lines and transactions when they please. In order to remove this necessary trust that people will do the right thing, people will keep a copy of their own ledger, and when they want to make a transaction, they'll write it in their own ledger and then broadcast that transaction to anyone else who has a ledger. If this is one big game of telephone, that begs the question, how do you ensure that everyone has the same ledger, or whose ledger can you trust? This introduces the idea of computational work, specifically the idea of a hash function. For many online securities, the SHA-256 function is used to create a hash. Messages and data are put through this function, and they create this hash. Essentially, it's just encrypting the message and the data like we learned in class. Notice how in these two examples here, when the message changes, the hash also changes very drastically in order to keep that data encrypted and unique. This idea sets us up for how cryptocurrencies are maintained and provide value. If transactions were the only thing being encrypted into the hash function, it would be easy to get the same hash if similar transactions were made. Therefore, there needs to be a special number that is included in the original data. Bitcoin specifically uses hashes that start with 17 zeros at the very beginning, as you can see with the red numbers here. This is to maintain the difficulty of finding the right plaintext to run through the SHA-256 function. Because of the difficulty of finding a hash that starts with 17 zeros, the chances of finding that special number results in 1 over 2 to the 17th power. The only real way to figure out a number that matches with the transaction is to brute force and check if the function results in a number with 17 zeros. This requires a lot of work, obviously, so this introduces the term proof of work. If you were able to find a number that combined with the transaction and you ran it through SHA-256, which results in a hash starting with 17 zeros, you've done a lot of work, giving you that proof of work. Now, we can recall the question, whose ledger can you trust? The answer to that is the idea of computational work. In the cryptocurrency world, you trust the ledger who has the most computational work done to it, or the longest block. We will now introduce the topic of what it means to have a blockchain, which we've probably all heard of before, in order to see which block is the longest, allowing us to find a ledger who we can trust the most. Again, like I said, we probably all heard of this term blockchain before. This is the idea of linking all those transactions we talked about previously into a chain. We link these transactions together by including the previous block's hash into the current block's data. This previous hash is included in the plain data that goes through the encryption. Because of the reliance on the previous block, this also ensures that if anything were to change in the previous block, all future blocks would be affected as well. So, who actually takes the time to find this proof of work, and why is it worth it to them? The answer is block creators, or also known as miners, who we've probably all heard of before. They work towards finding that proof of work, essentially racing against all the other miners to find the right special number, like we mentioned, for a certain transaction. After the block is validated by finding that proof of work, the block is broadcasted to everyone. However, what is the benefit to finding this proof of work? When miners are done validating this block, they are paid some of this ledger's currency magically from the stock of ledger currency. This rewards miners for their work and time by getting some of this currency in return. Because this currency is being added into the online economy, this allows for more money to be circulated through, thus adding more to the blockchain and adding more of that currency to be going through transactions. This time and effort is what allows people to trust this online ledger and allow people to earn this cryptocurrency. So, to review, we talked about this digital ledger that we call the blockchain. Each block generates cryptocurrency through the use of encrypting transactions. Each transaction is signed and proved by having these digital signatures that they encrypt through the use of cryptography, like we've talked in class. Another reason how cryptography works in combination with cryptocurrency is by hashing the entire block in order to keep it unique. The way these blocks turn into the blockchain is by including the previous block's encryption or hash in the new block. Miners are brute forcing numbers that, in combination with the transaction data, the signature, and the previous hash, using SHA-256, will get a number starting with the set amount of zeros. This is not an easy process, so those who manage to figure it out are given a proof of work, which is rewarded by some of that cryptocurrency. While this cryptocurrency network may be confusing to some, I hope by watching this video you are a little less confused. And finally, here is a list of our sources that we used for this project.